Okay, good. So also those who have joined computer science, you will also be doing AI machine learning courses, right? So of course, and those who have joined, if there is somebody from electrical electronics also, don't think that okay, you will get away with AI and machine learning. So all the streams, of course, they are indeed like looking at applying the AI machine learning techniques, right? If you see my background, of course, I am not a I am not like with the, I am not an AI and machine learning person, but then of course any stream, right? People working in any stream, of course, they now have to dive into AI machine learning domain, right? So we cannot get away with that, right? So the field is evolving. Everybody wants to apply the AI techniques, machine learning techniques to do improvements in their respective fields, right? So whatever stream it is, of course, everybody is looking into. Now this is the key thing that everybody is looking into, right? You will be applying these things, right? So, I thank all the members, the director and all the other members for the warm introduction. So I think the first few things are related to my background, but I think this is already mentioned. So I'll just quickly go over it. So I completed my bachelor's in 2017, and then like I completed my master's in 2009 from Eindhoven University, and then I continued to work there as a software design engineer until 2011. Then I moved to France for my PhD. So I completed my PhD at INRIA in France in 2015. After that, I worked for a few more years as a postdoctoral researcher in a couple of universities in Europe. So I was there for a couple of years at University of Aalto in Finland, and later on I was there in Sweden for a year. So then I have applied. I decided to move back to India. I applied here at IIT Bhubaneswar, and I joined as a faculty member at IIT Bhubaneswar in 2018, right? In February 2018, I joined here at IIT Bhubaneswar. So here at IIT Bhubaneswar, of course, I'm teaching. Of course, I like interacting with students, so I like teaching. So I teach our students various core courses, like to all the UG students, like I teach courses related to programming. I teach other core courses such as automata theory and compilers. How many of you have looked at your curriculum? How many of you have looked at you have a course curriculum, right? How many of you have looked at your course curriculum? How many of you try to look at it and try to understand like what kind of subjects you will be learning in these 4 years of journey? Okay, good. I see one hand at least. Okay, please have a look at the curriculum, okay? You at least will get some insights on what kind of courses you will do and so on, right? So have a look at the curriculum. So I think if you are joining the computer science, I think you all are in the computer science stream majority. So there are certain core courses in computer science like automata theory, right? So automata is like a state machine that is basically representation of like what computing machines can do, right? So there are core courses like automata theory and programming language compilers, right? Compiler design, all these things will be part of your curriculum, right? So I teach all these kind of courses to our UG students, and of course I also teach courses to our master students, like courses like software engineering related to software testing and so on, right? And with respect to the research, as I said, right, my main area is not AI and machine learning, but as I said, people working in any domain now have to dive into AI and machine learning, right? So my main area of research is on software engineering related to techniques for testing software systems. So that is my primary area of research. But then of course now the key focus is on AI and machine learning, right? So now people are applying AI and machine learning techniques to build systems. So when we apply these AI machine learning techniques, so now we need to see how to design like approaches for testing, validating those kind of systems, right, which use AI techniques, which use ML techniques, right? So we are looking into those kind of things, right? So yeah, so this is a brief outline of what I'll be discussing, but as I said, right, so don't worry if you don't get something. So try to see from the try to see like what points you can take in, right, from the application perspective, right? So what kind of applications will sort of interest you, right? What kind of things you will be doing. So of course I'll be focusing on what is being done rather than how it is being done. For you to understand how it is being done, I am sure you will have several courses in your curriculum, right? And once you do those courses, you will understand the techniques, methodologies, all those things. So I'll primarily focus on what these things are rather than how, right? So the how aspect you will understand gradually, right? Once you do your courses, right? So the first I will give a very brief introduction on what is AI, like what is artificial intelligence, right? What is data science, right? How many of you think the field of artificial intelligence is new, that has started recently? How many of you are with that opinion? Is there anybody who thinks that okay, the field of AI has just started few years back? Earlier nothing was existing. How many of you think that okay, the field of artificial intelligence is existing since several years, several decades? Is there anybody who thinks that? Okay, good. So indeed, okay, the field of artificial intelligence is not something new, right? Of course, things have boomed up in the recent years, but then the field of artificial intelligence, the term artificial intelligence, these were into existence in several years, right? So I'll tell you a bit of a history of how things evolved, right? And with some examples, right? So after a brief introduction on that, I will very briefly talk about what our group. So of course I am working with various other students in our institute, various research scholars on different problems. So what is our main focus? We are looking into the area of what runtime monitoring is. So I will very briefly tell about what this area of runtime monitoring is, and then I will talk about what we are currently doing, right? So how we are actually combining like the AI machine learning techniques together with our frameworks to propose new mechanisms, new systems, right? So how we are like combining things with AI machine learning techniques, right? And what kind of applications we are building, right, by these combinations. So I will tell very briefly about the kind of applications we are working on that are related to healthcare, that are related to autonomous driving, all these kind of things, right? Okay, so yeah, this first part of this talk, the content is the introductory part of AI and data science. The content is mainly, some of the contents are from the lectures from Professor Pallab Das Gupta from IIT Kharagpur, right? So I just wanted to acknowledge him. And the later part is mainly our work, right? What we are actually doing, right? Okay, so yeah, so what do you understand by the term artificial intelligence? So what does the term artificial intelligence mean? So there is intelligence and there is artificial, right? So what is what do you understand from this term? Yeah. Okay, very good. Okay, so like the notion of intelligence, right? So of course, like so when we talk about intelligence, it's mainly about human intelligence, right? But then when we use this word artificial intelligence, we are basically saying that okay, now is a machine actually capable of doing things that a human can actually do, right? Or in a better way than a human can do, right? Can a machine do something similar to human, right? So when we talk about the intelligence of a human, right? When we talk about the intelligence of a human, I think we all, have studied somewhere in our schooling that okay, when we think of how brain functions, right? The human brain functions. How many of you remember like reading some things about what a left brain does and what the right brain does? There is some notion, right, that the left brain is responsible for doing some things, right brain is responsible for something else. So I think you must, if you recall, you must have studied things like okay, the left brain mainly deals with logical things, right? So logic, the mathematics, all these kind of things are dealt by the left brain, right? Whereas the right brain like deals with things that are related to creativity, imagination, all these kind of things, right? You must have studied this somewhere, right? So the right brain basically deals with other kind of things, right? Other kind of arts, creativity, visualization, all these things are dealt with by the left brain, right? So now when we when we talk about artificial intelligence, right? A machine doing intelligent things, right? So when we talk about that, so there are certain classic AI methods. Of course, these are in existence in several years, right? There are classic AI methods that are related to logical reasoning and all those things that are under existence, right? So there are basically various symbolic methods which come under the classical AI methods, right? On the other side, nowadays, of course, we have we are able to store vast amount of data about different kind of systems, right? The sensor technology improved, we are able to collect vast amount of data. We are able to then now apply various kind of approaches that gather information by analyzing data that is stored, right? So on the other side, we have this statistical machine learning kind of methods, right? So this can sort of correspond to like what the right brain actually does, right? And this correspond, the classical logical methods, they correspond to what the left brain actually does, right? So now what is the modern AI approaches, what are they basically looking into? How to combine these two, right? Of course, both independently cannot work, right? Now there should be, in order to do like more novel things, these two should be combined, right? That is also how our human brain works, right? How our human brain works, how our human brain works, and where the left brain and right brain synchronize, right? It's not like the left brain does something and right brain does something else, right? When we take, for example, consider the case when we want to recognize somebody and when we want to initiate some reasonable interaction with somebody, right? So the left brain deals with things like, okay, recognition of the person, right, by visualization, all these things, right? But in order to carry out a logical like sort of interaction with the person, the right brain deals with the creativity, visualization, that deals with identifying the person, right? And whether we are carrying out a reasonable interaction with the person, that should be coordinated by the left brain, right? By logically thinking on what to ask, how to interact, and all those things, right? So how our human brain normally functions, it's basically the coordination of the left and right brain, right? So now when we want like modern machines to also do complex things, of course both these techniques should be combined, right? So both these things are actually combined to build novel approaches, right? Okay, so like before we talk more about what artificial intelligence is, so basically what is the meaning of intelligence, right? So how do we assess the IQ of any person? How do we assess the IQ of any person? So there are various elements involved, right? So to assess the IQ of any person, right? So there are various things like the knowledge that the person has, right? The learning ability, right? The communication, like the kinesthetic, right? How the person like coordinates, right? The planning. There are various things involved to assess the IQ of any person, right? So even the modern AI, there are various techniques that map with these different things, right? The modern AI technologies, right? So as I said, right? So if you are thinking that, okay, this field of artificial intelligence is very new, that is a wrong perception, right? That the field of artificial intelligence is in existence in several decades, right? So when was the first, when is this term actually invented? The term actually came into existence in 1950s, right? So to tell you briefly about, so what did we discuss about the notion of artificial intelligence? It's basically nothing but whether a machine can do something that a human will be able to do, right? So the human ability of a machine, right? We can say it something as a human ability of a machine, right? So in 1950s, right, in early 1950s, so Alan Turing, who is a researcher, he has proposed something called as a Turing test, right. So what is this Turing test actually? In a Turing test, there are actually three things involved, right. On one side, there is basically a person sitting on one side, right, who is trying to interact with the parties on the other side. So there are like two parties on the other side. So one of them is a human, the other is a machine, right. So this person sitting on the other side, like who cannot see like who they are, right, there are like two parties on the other side, he is trying to interact with them, right. So if the machine, right, so whenever the person is trying to communicate, of course it's not oral communication, right, it's communication through typing, right. So he gets responses by either of them. So if the person who is conducting this test is not able to figure out who is actually responding, whether it's a machine responding or the human responding, right, then it basically means that okay, the computer is as intelligent as a human, right, because the other person is not able to make out whether it is the computer on the other side that is responding or it is a human that is responding, right. He is not able to differentiate, right. If the person who is conducting this test is not able to differentiate on who is responding back to him, then it basically means that the computer is as intelligent as a human, right, because this party who is conducting the test on the other side, he is unable to make out whether the response is coming from a human or from a machine, right. So this is like this sort of Turing test, it existed several decades back, right. But now I think the similar kind of things, right, how many of you are using the computer voice assisted things? So I think everybody is using voice assisted like chatbots, right, yes or no? I think in all your mobile phones you have different things, right, yes or no? So like Alexa or whatever, right, you are using different kind of chatbots, right, that is basically like a machine that is talking to you like a human, right, that is trying to help you like a human, right. But existence of these kind of things were defined several decades back, right, like in 1950 this kind of Turing test is defined, right. And yeah, I just wanted to mention very briefly about how this field evolved, right, how this field actually evolved starting from 1950, right. As I said, the first seeding of this was through this Turing test. I just mentioned about what Turing test is, right. So how this actually began by the proposal of this Turing test by Alan Turing, right, that I just mentioned what it means, right. So then eventually like later in 1950s, so the term artificial intelligence came into existence, right. In 1956 this term came into existence, right. They have officially like proposed this term artificial intelligence, right. So this happened in 1956. So it's not something new, you can see when this term actually came into existence, right. It's in 1956, right. So then later on a lot of things happened from 1956 until very recently, right. So what happened after 1956? So then in 1969, so the researchers at Stanford, they actually built the first robot with self-reasoning, right. So that is what was built later on after a few years, right. That happened in 1969, right. So then later on, these kind of artificial intelligence techniques, they started to evolve, and what kind of languages were commonly used to build these AI based approaches? They were commonly using languages like Lisp, right. How many of you have heard about Lisp language? How many of you have heard about Lisp language? Or how many of you know some programming language? How many of you know some programming language? Okay, what are the programming languages you know? Python? Okay, so now. Any other programming language? C and C++, right? Okay, so yeah, these kind of, so if we talk about languages like C, C++ and so on, right, Python, they are basically procedural languages, right, the imperative procedural languages, right. But if we go back several years back, so there were other kind of languages also that were commonly used. So Lisp is actually a functional programming language, right. There are other kind of languages like which fall under the logic programming languages, right. So in the earlier days, so for implementing these AI based techniques, so Lisp and other kind of logic programming languages were commonly used. So lot of systems were built using Lisp around 1980s, right. But gradually, like in the after the next few years, the prominence of this Lisp based implementation of this AI systems is gradually reduced, right. Why this happened here around 1993 and so on? So why this actually kept reducing? Why it happened in this period? Because during this period, even the programming language community has evolved, right. Lot of imperative languages, procedural languages that we are using now, right. So they came into existence. They actually evolved, right. So what happened in these years? So after these kind of imperative procedural languages came into existence, so the demand for Lisp based machines it kept reducing, right. So later on, like even for this building this AI based systems, the other kind of procedural imperative languages were used, right. So then what are the other few milestones that happened afterwards? So if we see few other milestones, right, in 1997, so this IBM Deep Blue machine was built, where the machine actually was able to defeat Garry Kasparov. Garry Kasparov was the chess champion in those years, right. So IBM has taken this challenge. It has built a machine and a technique over that machine, where this Deep Blue machine competed with the chess champion in those years, right, who was Garry Kasparov, right. So that particular machine was able to defeat this chess champion in those years. So this created a lot of sensation all around, right. How could a machine defeat the chess champion, right? But this actually happened, right, in the year 1997, right. So then over the years these things actually evolved, right. So later on in 2008, right. So later on in 2008, you can see here, right. So this happened in 1997. Okay. So as you can see, right, later on you can see the gap here, right. So this this IBM Deep Blue, this actually happened in 1997, right. But later on in 2008, so we can see the gap here, right, 1997 to 2008, right. So why is there so much gap? So later on in 2008, what actually happened? So these kind of AI based applications were also executed on simple machines like mobile phones, right. I think now everybody is using some speed search kind of application, right. How many are using speed search kind of application? Like the voice search applications. So it must be there in your mobile, right? Must be there in your mobile, everybody should be using, right? So if we see these earlier days, right, in 1997, these kind of AI based applications, they actually needed huge resources, right? Huge resources, lot of computing facility was required. But over the years, 1997 to 2008, over the years, they were able to bring such technology also on common machines, right? On simple machine like mobile phone, so we were able to, I think people were able to run these kind of AI based applications, right? So what was the first simple application that was running on a mobile phone, AI based application that was running on small device like a mobile? So it was this Google Speech to Search that was sort of proposed for an iPhone proposed as an application for iPhone, right? But nowadays, I think it is there in every device, right? Every sort of handheld device has these kind of features, right? But this first came into existence in 2008, right? As a feature for iPhones, right? So then, of course, a lot of other things happened over the years, right? Then in 2011, then IBM built another machine. So Jeopardy is like a quiz, sort of like we all watch KBC, right? How many watch KBC? So we all watch like this competitions like KBC, right? I think Jeopardy, it was like a similar thing that happened in US and other countries, right? Which was like this quiz competition. So IBM has actually built a machine and an approach that was again able to defeat like champions in Jeopardy, right? So that actually happened in 2011. Then, then later on in 2011-12, so Google also developed features for identifying different things in videos, right? For example, it was able to identify cats in all the videos, right? Analyze a video, identify cats, for example, right? So those kind of things came into existence in 2012. And a lot of things happened in that decade, right? 2012, 13, 14, 15, lot of things happened, right? A few examples like how many of you are using iPhones? So there is like the Siri in iPhone, right? Like Alexa, right? There is Siri app in iPhone, right? So these things came into existence in 2012, right? I'm sure everybody uses Facebook, right? Everybody is using Facebook, yes or no? No? So this is surprising for me. How many of you do not have an account on Facebook? Okay, who is having an account on Facebook? So this is surprising. How are you not using Facebook yet? Are you using any other, okay, you are using other kind of social media application. Okay, now I understand. Or you are building your own application maybe. Okay, so if you are using these kind of social media applications, right, like Facebook, right? So if you recall, I think there are features where these kind of applications, they recognize persons, right? It's if somebody uploads a photo, it basically tells this is a photo of your friend, right? Somebody like who is in your friend's network, right? It basically, how does it show in your scrolls? It basically recognizes that that photo uploaded is somebody who belongs to your network, right? So a lot of these recognition things like were done by companies like Facebook and so on. They came into existence in 2014. And of course, one great sort of revolution or sort of thing that happened in 2015 is like these companies like Google, right? They have built various libraries that will help in developing these AI-based systems, right? I'm sure everybody will like eventually use these kind of libraries like TensorFlow, right? TensorFlow is a library that has several features that will help us in building these AI-based systems, right? So what happened in 2015, like the Google company like decided to make it open source. Open source in the sense, of course it is developed by the company, but it thought that for the benefit of the community, it thought, okay, it will make it freely available to everybody, right? So since these kind of libraries were made freely accessible to all research communities and everybody, so people started to use these libraries, and nowadays we know different kind of applications are being developed by all of us, right? How did this happen? Because lot of such libraries that are designed and built for AI-based systems, they are made open source, right? So now we are all able to use them. We are able to apply them for building different kind of applications, right? So these things, different things happened, and what eventually happened also in 2016, how many of you know what a self-driving car is? What is an autonomous car? What is a self-driving car? Self-driving car means Tesla, or is there any other company that's also working on this self-driving features? So self-driving in the sense, of course, without any human driver, right? The car has features to navigate itself, right? So of course there are different levels of autonomy. if the car is completely autonomous, then of course it should be able to navigate and do everything completely without a human driver, right? It should be able to function completely without a human driver, right? So what happened in 2016, so Uber actually like sort of released self-driving cars in some parts of the US, right? It's self-driving sort of cabs in some part of the US, right? In Pittsburgh, for example, right? But what gradually happened later on, in 2018, what actually happened later on in 2018? So these vehicles, these kind of self-driving systems that are released, right? They are again like banned in some parts of, in most of the parts of the US. So why do you think these things are banned later on? Of course, they started so slowly from applications related to sort of social networking based features and text to like speech to text and all these kind of things, right? Voice assist. Now things also have moved to like vehicles systems like cars, right? So these kind of AI technologies were also used to build these self-driving features, right? AI and data machine learning technologies were used to build these self-driving capabilities, right, in vehicles, right? So they started these kind of things, but eventually they were stopped. So why do you think that these kind of things were stopped? What could be the reason? So what could be the reason? So anybody who want to say like why these were stopped? It is good, right? If I'm having this sort of self-driving thing without a human driver, that is good, right? If I'm able to do that using applying AI ML techniques, people have done that. People are still doing that. This autonomous driving, this is like taking a rapid shape, right? Even a lot of car manufacturing companies are investing in this, right? A lot of companies like Toyota, everybody is working on these things, right? So when people have succeeded, it started, and why it actually stopped? Why did they ban those things in 2018? So that is a valid point, but that is not the actual main concern, right? Sorry? Okay, but of course if the system makes sure that otherwise, so it will be tested, right? If it is made sure that, okay, so of course you raised some concerns, of course the drivers may lose their jobs, but there are other, so that is one side of the story, right? If the thing is usable or not, right? That is like the main concern, right? So now when we talk about applying this AI ML things in systems like sort of in social networking things like Facebook, or in building this voice assists, right? So they are fine, right? Because those kind of systems are not safety critical. Yes, those are not safety critical systems. So what is a safety critical system? If there is some malfunction in the system, then of course it may cause like severe harm to people, right? So of course if a voice assist fails to deliver some outcome to me, that is fine, it's not going to cause any harm to me, right? Or if this kind of thing applied in Facebook or other kind of social networking thing, if it is not going to prompt appropriate photo or something to me, that is fine, it's not prompting, it is fine, right? If it misses prompting something, that is fine, because it is not safety critical in nature, right? But think of applying these in systems like cars, in planes, so, or in medical devices. So systems like medical devices, systems like at cars and other kind of vehicles, they are all safety critical systems. Why are they safety critical? Because any minor malfunction of those can lead to severe consequences, right? So safety of such systems is very, very important. We should always ensure safe functioning of these kind of systems, right? So why were like So these kind of techniques were built, they were launched, but then they were withdrawn after certain period, right? It doesn't mean that they have stopped working on autonomous driving. Now, like lot of companies and lot of research groups across the world are working on autonomous driving. Right? It's not like they have stopped, but then they have recognized that whenever these kind of AI and machine learning based techniques are applied in systems that are safety critical in nature, they should have other rigorous ways of ensuring that the system will be working safe, right? So there should not be any chances of failure, right? If the vehicle has to do a braking, it should do the braking at the appropriate time, right? Whenever it sees somebody crossing, right? Whenever it sees an obstacle, it has to do the braking at appropriate time, right? It cannot miss something from happening, right? So people are it is not like people have stopped applying these things to safety critical systems. There are a lot of companies, lot of groups still working on these kind of things. At the same time, they are investing on, also working on how to test those kind of AI machine learning based schemes that they have used in these kind of systems, and how they can ensure that once they use these techniques in the system is not going to fail, right? So those kind of works are going on, right? To be able to apply them, of course, people are able to apply them. But once they use this AI ML techniques as a part of a safety critical mission, safety critical system, they should also make sure to rigorously test and verify those things, right? Such that the system is never going to fail at all, right? The safety of the system is ensured, right? So now what is the key thing like people are working on? How to ensure safety of the systems, right? Whenever we use this kind of machine learning AI things, how do we ensure the safety of the system, right? Okay, so yeah, this is like just a snapshot of the picture from, as I said, right? So this is the IBM like the machine, right? That actually like defeated the chess champion during that period, right? This was around when did this happen? 1997, right? So around that period, right? So you can see, right? So you can see the setup of these machines, right? There were huge, like high performance computing machines used, right? But that was back around 1997, right? So now in addition to like evolvement in the field of technology related to AI and ML, in parallel, even the hardware industry has evolved, right? What is the difference between 1997 and now, 2024? We all also know that, okay, the hardware industry also has evolved, right? Now the size of the processors, the size of these, sort of memory, the size of these chips, it has drastically reduced, right? And now we are able to even support doing several millions of computations also in our mobile device, right? I can have a very powerful mobile device that has like very powerful processor, lot of memory, high-end GPU, everything, right? It need not be this large. I can do it on a compact device, right? So why? Because on the other side, the technology related to semiconductors, this hardware industry, it also gradually evolved, right? We don't need these like huge capacity things. Everything has shrinked in size, right? We can support a lot of sort of high capacity, hardware on smaller devices, right? So just to mention about a few areas of focus, right, of where people are looking at applying these AI techniques in India, right? What are the fields? What are the application domains, application fields, right? That hopefully you all will be working on in the near future, right? So there is a lot of focus, also like lot of groups, research groups, also a lot of government, sort of groups. They are focusing on adapting AI schemes in different fields, right, in different application domains, right? So one of the areas is related to healthcare, right? Of course, like we are a very huge population, right? If we can bring in techniques using AI, so nowadays we can Now things are different from the earlier days, right? So now we are able to now the memory has become cheaper, right? If we take older days where, like, buying a small sort of RAM or buying a small memory stick used to be very, very expensive 30 years back, right? But now they're quite cheap, right? The storage is quite cheap, right? And now the other technology also has improved, right? Related to sensors, the sensor technology, right? So now about when we want to work on healthcare related fields, now there is a lot of feasibility to collect different health related parameters of a person, right? So we can collect different health related parameters of a person using different sensor technologies, and all the data can be stored, right? So once we have a lot of health related parameters of different persons available, we could apply different artificial intelligence and machine learning techniques to do a lot of inference, and to help with how to to come up with mechanisms for preventive healthcare, right? Automated approaches for preventive healthcare, right? So there is a lot of focus on how these AI machine learning techniques can be used towards healthcare, right? And of course, like, we rely a lot on agriculture. So there are a lot of missions going on how these artificial intelligence, data science, machine learning, how they can help with improvements in agriculture related fields, right? So can you give me a few examples how these data science, machine learning, AI techniques, how they can help in the domain of agriculture? So what do you think? In what ways, gathering information, analyzing the information using different techniques, how intelligent systems can help in the field of agriculture, for example? You want to say something? Yeah. Okay, farming and plantations. Okay. How with farming? How will it help with farming? So for example, okay, Sina, good, Sina. So yeah, so what could be different challenges like that our farmers they might be facing, right? If we talk about few examples, right? One example could be that they may not know, they may not know when the climatic condition may change, right? Due to sudden change in climatic conditions, they may be worried about the entire crop may be lost, right? Yes or no? Yes. And they may be concerned about, okay, so now they have to frequently visit different spots, and they have to check different parameters about the soil, right? If some parameter changes, again the crop may be infected, right? So there are different concerns that they have, right? So how the AI related technologies they can help there? Of course, the AI related technologies can help there by doing some predictive assessment of how the weather conditions may change, right? By sending alerts to the farmers, right? And they can also be technologies where different sensors can be placed in the field, and these sensors can collect different data about different parameters in the field, right? About moisture in the soil and other kind of things, right? And using that information, there could be some assessment done on, okay, how likely the farmer should actually use some sort of pesticide or something to help the crop growth to be improved, and so on, right? So now we could use different sensor technology, gather a lot of data, right? And all this data could be automatically analyzed using AI/ML techniques. They could be of assistance to farmers, right? To give them better suggestions to take preventive measures, right? Another example could be that, okay, now we all are using different kind of chatbots, right? Yes or no? Yes, Alexa and all these kind of things, right? So the difficulty, look, even like when we see this field of farming, right? So the farmers might actually want to get some help, suggestions about how to improve their crop, right? What kind of pesticide to give and all these kind of things, right? And they may want these suggestions to be coming in their local language, yes or no? Yes, for example, like if a farmer like from state in Odisha, of course they may feel better if there is some sort of assist, automated assist he can use, with which he can converse in local language Odia, right? Yes or no? Yes. So lot of people are working in these kind of language models, right? Using local, Indian languages, right? Specifically related to agriculture, how the farmers can use these kind of, chatbots, these things to interact to get some queries answered, right? That will help them to, take preventive measures, right? So these are a few examples. And of course, lot of other fields, right? Like intelligent transportation system, retail, manufacturing, energy management, right? Smart cities, and also in education and skilling, right? So there is also, of course, plan to use, there are different missions going on how these AI techniques can be used for, can be helpful in building different, techniques that will help in education and skilling, right? Yeah, so when we look into like different AI technologies, right? So we can actually categorize them into different things, right? So that there are technologies that are related to sensing. Of course, like we need to collect data, right? Sense data, collect data, right? So there are technologies related to computer vision, so that can actually see the surroundings and then sense the surroundings, right? There are techniques related to identifying the speech, right? So identifying the speech and sense. So sensing is very important, right, for AI related, building AI and machine learning related, because these kind of systems should be sensing, collect information, they should process that information, right? And sensing is not just sufficient. Of course, there should be techniques that will allow us to comprehend, right? So let us say that, okay, so what is the way to observe the surroundings, like these kind of AI systems. So one example of a system is an autonomous car, right? How will an autonomous car observe its surroundings? How will an autonomous car like see? So if I am a human driver, if I am sitting in the car, of course I will see the surroundings, I will take appropriate actions, right? But then if I am talking about an automated driving car, how will it see the surroundings? How is an automated driving car going to see the surroundings? Yeah.
Sir, it uses LiDAR and ultrasonic sensors and camera image recognition.
So LiDAR, ultrasonic sensors, and of course there are different kind of sensors, right? And as you said, the camera is there, right, to basically see the surroundings, right? So there are different kind of inputs, right? This camera is basically like a vision, right, to an autonomous driving car, right? But just visioning, just seeing something, can it do something? So can it take an action just by seeing something? No, right? It cannot really take an action just by seeing something. So the approach has to, so we need to have some way of processing the information, right? Whatever information is seen, it has to be represented in some format, it has to be processed and represented in some format, right? The data has to be represented in some format, right? So we have like for comprehending or understanding whatever is observed, we have techniques related to language processing, right? You will be learning some techniques related to language processing, right? And then there are techniques related to how to represent the information that is comprehended, right? So the knowledge representation approaches are there, right? So once I have understood and once I have represented the information in some format, then I can apply different schemes to do the analysis, right? So then we will be applying different schemes, learning and AI schemes to do the analysis, right? Okay, so how many of you are still there with me? How many of you are following? How many of you are hungry? How many of you are hungry and want to go for lunch? So we can continue, right? We can continue for some more time. Hungry? Okay, so yeah, so so if we see like what these AI-based approaches are capable of doing, right? So what are the core capabilities of these AI-based schemes? So AI-based schemes can be applied to solve problems related to, constraint satisfaction. We could apply these schemes to solve different optimization problems, search problems. I'll give like a couple of examples of these. And the techniques can also be applied like for planning related problems, right? So I'll give one example of this as well. And of course, like for logical reasoning, so we'll discuss about with some examples. And mainly the ability to learn, right? So there is a lot of data that is gathered and observed, and there are different schemes on how to infer something from different data that is gathered, right? What can we learn from that, right? And the ability to handle uncertainty, right? Of course, like we don't really know what can come in from the environment, right? There are different uncertain things might happen, right? How will an AI system handle uncertainties, right? And how does it interface with the real world, right? How these systems interact with the real world, right? There are a lot of things that you will be learning in different courses that you will study related to artificial intelligence and machine learning, right? So I mentioned about using these AI-based techniques for problems related to constraint solving and optimization, right? So I'll just mention one example. I'll talk about one example related to this. So I'm sure everybody, we are using this Google Maps, right? Or other kind of map services. Yes or no? Yes? So what will we use it for? What do you use it for? So you are basically at some point and you want to reach some point, right? So you will be asking, what is the route to go there, right? I am at some source point and I want to reach some other point, right? Maybe you want to go to DN Regalia to watch some movie. So how do I go to DN Regalia, right? So you will be basically saying, okay, I am at source, this is my destination, show me the best route to go there, right? And it will give us the route, right? Now this is a simple. So maybe like, okay, you don't want to take a longer route, right? Your motive is to go to your destination in the shortest possible route, right? So you basically will ask, okay, give me the shortest path, right? Yes or no? Yes. Now like a question from you might be that, okay, now why do we need artificial intelligence? Why do we need this data analytics, machine learning techniques for this, right? Can I just apply normal like algorithms? So I think in some of the core computer science courses, you will be having a course related to computer algorithms, right? Algorithms. So in the algorithms course, you will be studying different graph related algorithms and so on, right? And you will also be studying different algorithms related to finding shortest path. So there are like core algorithms that will help us to solve these kind of problems, right? Then what is the use of data? What is the use of analyzing data, applying AI, these kind of things? In this field, you might be having that question, right? So now if the question is simple like this, right? If I know the map, and if I have the representation of the map, right? If I have all the information about the map, right? What are the different points, different nodes, different paths? If everything is known a priori, then of course that will boil down to traditional shortest path finding algorithm, right? I could implement that. But our needs of using these kind of services is growing, right? It's not just finding shortest path. Somebody might say that, okay, I want to find a path with minimum congestion, right? I want to find a path with minimum congestion. So then the environment actually is dynamic, right? It's not like a fixed point, fixed paths from these one point to another point. At that moment in time, like what is the traffic scenario, Yes or no? Yes, the environment is not a fixed environment, the environment is dynamic here, right? Now it may be even more complex, and the user might want to say that, okay, I wish to find a path where I might have different options for transport available. So there should be an option to use a metro service, or a bus service should also be there, or other kind of taxi service also should be available. Now there are different kind of constraints coming in, right? Yes or no, depending on the needs of the user, right? And maybe something more specific, right? Maybe in the path I want to pick some medicine, for example, right? Then I might ask, okay, give me a path where there is also a medicine shop in my way, right? To reach my destination, in the way of my destination, I should also find a medicine shop, right? So when these kind of and if you are using an electric scooter, how many of you are using electric scooters? Now I see a lot of electric scooters are being used, right? So now if you are actually using an electric scooter, then your query might be that, okay, now give me a path that also minimizes the energy consumption of my battery, right? If your battery is running low, you don't want to take slopes, because if you are taking something that where you have to climb a bridge, right? You may want to avoid those paths, right? Because that might consume more battery, right? So now with all these things changing, right? So now these kind of applications should be more intelligent, right? And how we could build more intelligent sort of these applications by taking the current scenario, the dynamic environment into account, by applying other kind of analytics, so we can build more sort of robust applications, right, for these kind of systems. And as I said, right, so if the complete knowledge about the domain, so here what do I mean by domain knowledge? It's basically all the information, right? So when I'm talking about searching on a map, it's about all the information about the environment, right? So here my environment is the map, right? The routes, the different points, and all these things. If everything about the environment, about the domain is completely known, then I might think of some techniques. But in some of the problems, right, in this search problems, maybe I don't really have all the information about the space I am exploring. Yes or no? Yes? Only that might also change over time, right? That might also change over time. For example, the traffic scenario, it changes over time, right? Yes? So then it's really important to also analyze the data that is coming in. So we should have different kind of ways to analyze what is the information currently. It's not like a static information about the environment. What is the other data that is coming in, right? How do we analyze the data to take appropriate actions, right? To take appropriate actions dynamically. So there are other kind of learning techniques like reinforcement learning that also takes into account the current data, right? It keeps on the decisions it makes, it keeps on evolving with the fresh data that it observes, right? You will be studying about reinforcement learning and other kind of approaches, where if you are applying these kind of system, if you are building a system based on reinforcement learning, the reinforcement learner also, in order to improve its decisions over time, it also like keeps on collecting data. As the system keeps on executing, it will keep collecting data, right? Based on the new data it observes, its actions also keep changing, right? It will improvise its actions, right? So as I said, now like modern artificial intelligence techniques, they aim to combine learning from data, so they keep on continuously collecting data, right? And how that data can be used to improve its actions, right? Together with the structured domain knowledge. Whatever knowledge is available about the domain, it makes use of it, right? But then with the new data that it collects from the environments and it maintains, so it keeps on improvising the actions based on the new data that it collects, right? So the techniques are evolving where both these kind of standard things and the data-based analysis things are combined together to bring up novel solutions, right? Okay, so just one more example on so we talked about application of AI for problems related to constraint solving, problems related to optimization, right? So this is one example, right? So there are like AI techniques used to solve planning related problems. Okay, so let us see one example. We'll just talk about one example here. So consider like this scenario here, right? So let us say that, okay, now we have like this is the initial scenario. Okay, we basically have load and there is a truck, right? And there's a crane. What is to be achieved? The thing to be achieved is shown in this block that is below, right? Block number labeled as S5, right? What is to be achieved? Finally, what should happen is the truck should be in location 2 and the load should be on top of the truck, and that such that the truck will be able to move and deliver the load, right? The initial scenario is the load is in location 1, truck is in location 2, right? And what is the final scenario to be achieved? The load should be on the truck and the truck should be in location 2, ready to sort of depart, right? So what are the different ways of achieving this? How can I come from this point to this point? So there are different ways to come from this point to this point, right? So what is to be done? So what could be one way of coming from this point to this point? One sort of route could be, first the truck can move from location 2 to location 1, right? And then the crane can lift the load, right? And drop the load on the truck, and then the truck can move back to location 2. So that is one possible sequence, right? What could be another possible sequence? Another possible sequence could be that first the crane lifts the load and then the truck moves and so on. Yes or no? Here there are different possible sequences, right? There are different possible sequences, right? So what in general, what does planning problems deal with? The planning problems deal with these kind of things. There is an initial world, right? When we talk about planning problems, there is an initial world. So what is my initial world? Is the initial status of the system. So what is the initial world in this example? Initially the truck is in this location, location 2, load is in location 1. So that is my initial status, right? What is the goal that I want to achieve? What is the goal that is to be achieved finally? The goal to be achieved is the truck should be in location 2 with the load on top of it. That is the goal to be achieved, right? Yes or no? Yes. So what does the planning problem basically deal with? Given the initial world, right, and given the final world and a possible set of actions. So what are the possible set of actions here? The possible set of actions could be truck moving from location 2 to location 1, right? Crane lifting the load, crane dropping the load. These are the possible actions that are possible in the system, right? So given an initial world or an initial state and a final world or a final state and the possible actions, so what is a good sequence of actions to come to the goal, to achieve the goal, right? So a planner basically tells us, given these initial and what is to be achieved and possible actions, a planner will tell us what should be a good sequence of actions to achieve what I want, right? So that is basically so of course we are going over a bit faster. So as you can understand, right? So how many of you are here have heard about term robotics? So robotics is not uncommon, right? So everybody is familiar with what robotics means, right? So robotics is applied in different kind of fields, right? So if we are looking into sort of robotics and these kind of things, right? These kind of planning problems are quite common. They are to be solved in robotics, right? Even the autonomous driving is sort of similar problem, right? So when we look at this modern AI techniques, right, they basically deal with how these kind of planning problems, how solutions for solving these planning problems can be combined with other machine learning techniques to achieve like more complex things, right? For example, to achieve like desirable things in autonomous driving. So what could be one desirable like sort of event that we have to deal with when we talk about automatic driving? So one event could be to overtake, right? My vehicle is going and I want to overtake, right? So what could be the sequence of actions to perform overtaking? So can I overtake by staying in the same lane? Overtaking cannot happen by staying in the same lane, right? So the sequence of actions could be that, okay, first I need to move to the adjacent lane, right? Then I have to give more throttle or whatever, right? Then I should come back to the same lane. So there should be some sequence of actions that should be done, right? So now you may say that, okay, why can't techniques like that are applied in planning, they can be applied to derive these sequence of actions, right? Of course, we can derive that, but then when we talk about autonomous driving, right, there are a lot of things that come into picture, because this overtaking also depends on the current scenario of the road, right? Yes or no? The current data, what is going on in the current scenario, right? Yes. And it also depends on a lot of other current factors of the vehicle that we are trying to move, right? Yes or no? What are the other factors that, so there are lot of data also has to be taken in addition to planning that tells about this is the sequence of steps. Do you all agree that lot of other data has to be analyzed in order to make the overtaking, yes or no? Or is just planning sufficient? Just standard planning will not suffice, right? When I'm talking about autonomous driving. Of course, we need the standard planning to derive the sequence of actions, but then to carry out that, I need to also make sure about a lot of other things, right? Yes or no? Yes. So for that, of course, we definitely have to combine planning with other kind of data analytic things, right, in order to perform these kind of tasks, right, in domains such as autonomous driving, right? Okay, so I will give a couple of more examples if you are okay with that. Is it fine? Are you okay with it? Yes? Okay, so coming to few other applications, right? So there are few other applications where these kind of artificial intelligence techniques are used, like logical reasoning, right? So I think you will study a few courses where you will learn more about logical reasoning. But in a general sense, what do we mean by logical reasoning? So logical reasoning basically means that, okay, how can we automatically deduce something that is unknown to us from the facts that we know, right? From the information that I know, how can I use the information that I know to deduce something that is unknown, right? So that is basically like what logical reasoning deals with, right? So there are various applications of logical reasoning. So one of the key application is related to automated theorem proving, right? Maybe you will learn about theorem provers. Theorem provers are sort of verification techniques that are used to verify whether something is correct, right? Some approach or some technique is correct, right? Or some statement is correct and so on, right? So these kind of theorem provers are built, and then a lot of like interesting things are also proved, right, using these theorem provers. So I'll not talk more about this due to the time constraints, but maybe I will explain what these mean, what logical reasoning means and so on with a simple example with which you can easily connect with, right? So if we take the example of, relations among humans, right? If we take the example of relations among humans, so if we have something like this, right? So if father of z is x and father of y is z, then I can deduce that from these facts. What can I deduce? I can deduce that the grandfather of y is x. Yes or no? Yes, I can deduce that, right? So similarly the other things, right? If I have this information, father of z is x, mother of y is z, then what can I deduce from this? The maternal grandfather of y is x, right? That can be deduced, right? So this is what is meant by logical reasoning, right? If we take a simple example, so this is something that I know. What can I deduce from what I know, right? So these are other things, but then okay, finally, like if we have something like maternal great uncle, right? I'll explain this with an example. if we take this picture, right, is this readable properly? I am not sure if the fonts are readable. But then if we just see this relation tree, right, if we see this example relation tree, right. So here if we see this node, the second node from the bottom, right, which is the name is Freya here. So what can we say about the relation between Freya and Fergus? So the name here is Fergus, right? So how is Freya related to Fergus? So Fergus is the other highlighted node here, right? This is Freya and this is Fergus, right? What can we say about the relation between Freya and Fergus, right? So what do I know? So we can, from these observations, right? Who is the maternal grandmother of Freya? The mother of Freya is Jo, and then mother of Jo is Charlotte. So can I say that the maternal grandmother of Freya is Charlotte? Yes, so I can say that, right, by applying one of the rules here. And what can I also say here? The mother of Charlotte is Lindsay, right? Mother of Charlotte is Lindsay. Yes? And the son of Lindsay is Fergus. Yes or no? Yes? So then what can I deduce from all these? So I have this information, so what can I deduce from this? I can basically deduce that the maternal great uncle of Freya is Fergus, right? So this actually is based on this rule that is highlighted here, right? The maternal great uncle of Freya is Fergus, right? So this can be deduced, this relation among Freya and Fergus is deduced using this logical reasoning, right? So I have this connections and that can be deduced by applying these rules, right? So now how will this help in building any sort of, the AI based, application? So let us say how will this might actually help, right? So now we have like these different kind of days, right? There is Father's Day, Mother's Day and so on, right? Let us say in future there is something like maternal great uncle's day, right? So on maternal great uncle's day, maybe like, okay, this Freya is on some social media, application, using some social media application, and also Fergus is using some social media application, right? So what might actually happen by combining these sort of logical reasoning with other AI based techniques? We might actually, like these kind of social network applications might actually give reasonable suggestions to the users, right? It might, on maternal great uncle's day, Freya actually might be suggested with a photo of Fergus saying that, okay, today is maternal great uncle's day. Do you want to post this picture of your maternal great uncle, Fergus, right? So that might actually happen automatically. How many of you are getting such notifications? So these are also still currently there, right? These kind of things are already implemented in different kind of applications. We get such notifications, right? Today is, so, but they may be simple like things, like today is birthday of your friend, do you want to wish him, right? But this could be expanded to do other kind of complex things, right? But in order to do that, is logical reasoning just sufficient? So logical reasoning is not just sufficient, we need to combine with other kind of things, right? We need to combine with other kind of AI and data analytic things. For example, to identify and tag photos, right? For example, some photo of Fergus should be automatically identified as photo of Fergus by the system, right? So there are different recognition applications that will identify and tag photos, right? So that approach combined with logical reasoning might help to implement these kind of features, right? Yes? Okay, so I just wanted to make here one important, sort of distinction, right? I think over, like when you do different courses, you will actually learn that, okay, now whenever you are building or developing any system, right? If you are building or developing any system using traditional engineering techniques, right? So there is a difference between traditional engineering techniques versus machine learning techniques, okay? So now if you are implementing any system using traditional engineering approaches. How do we build any system using traditional engineering approaches? So first we need to understand what are the features that the system, what is the functionality the system should actually support, right? We have an understanding of that. Then we carefully think of how the system should be implemented. We make a clear design of the system that we want to implement, right? What function should be there, how the function should communicate and so on. And then we programmers, humans, we actually implement those different functions or procedures, right? So the program is implemented by us. We design the program, we implement it, right? That is what happens in traditional engineered systems, right? Yes or no? Yes? You agree with that? Yes? So the program is basically designed by us. So we know the complete internal details of the program of the system we build, right? Because we are carefully thinking about it. We are thinking of what procedures, what functions should be there, and we are carefully thinking of how they should interact and so on. And we are implementing it as a program, right? We are coding it, right? So when we talk about any traditionally developed system, of course the program is built by us humans, the engineers, which will take any input data and then which should, when we expect it to give the expected outcome, right? When I run the program with some input, when I run the program or the system that I have designed or a group of engineers have designed with some input, we expect it to give some outcome which is the desired expected outcome, right? But when we talk about machine learning techniques, the story is different, right? It's not traditional engineered system, the story is different. What do we use these machine learning techniques for? So whenever we are saying machine learning, right? The machine is learning something. It's not engineered or designed by a human. Any sort of traditional software system is engineered or designed by a human, right? As I said, we are carefully thinking of how the system should be built. We are coding, we are implementing it. But when I talk about techniques like machine learning, right? What we are throwing at the machine learning technique, I am throwing a lot of data at the machine learning technique, right? There is a lot of input data and the corresponding output data. So there are different input parameters, input variable, input elements. There are a lot of output elements that the system should generate, right? So from the lot of observation, I am throwing at the machine learning approach a set of inputs and outputs, right? Which could be a large data set, right? And now we are asking the machine learning approach, and this, the number of input parameters, the number of output parameters, how they are related, it may be very complex. We don't actually know anything about it, right? We only have the data, we are throwing it at the machine learning approach, right? And now we are asking the machine learning approach to give the program to me. So this is completely different from the traditional engineering way, right?